Hello again. This lesson we're going to be covering polymorphism and inheritance. So, let's begin. Inheritance and polymorphism in Python. Now obviously when I talk about inheritance I'm talking about money and flash cars, right? And when I talk about polymorphism I'm talking about, well, polymorphs, like magic. Like Professor McGonagall, who could turn into a cat, or Sirius Black, who could turn into a dog. No, unfortunately, I'm not magic. I'm dyslexic, so I failed the spelling test. No, pause for groans and maybe a few laughs. Now, inheritance and polymorphism are actually concepts to do with OOP, not in fact magic and rich relatives. So, let's do a little recap. What is a class? So, a blueprint used to make an object. What information does it contain? It contains an object's attributes and describes the behaviour of the object through methods. What is an object? An instance of a class. And then I'd ask them to remember the tea analogy, which is that you can't drink a blueprint, you can use a blueprint to make a cup of tea, and you can drink the cup of tea. So what method does a class use to create an object? So I'd ideally be looking for underscore in it, but otherwise just saying an initialization method. Again, I've used two N's there, my apologies. So, inheritance. Inheritance in object-oriented programming describes a class that inherits certain attributes from a subclass. So, there are two types of classes. A superclass or parent class, so you can imagine this as being at the top, and this is the class that others inherit from. It spawns other classes you can think of, and a subclass or child class. Now, this is the class that inherits from the parent. So, let's say that your parent's a superclass and you are a subclass. You've inherited certain genes from your parents, so height, eye colour, hair, skin colour, that's all tends to be inherited. But you're also unique and you have attributes that your parents don't. Maybe some of you play the trumpet and your parents don't. Maybe some of your parents play guitar but you haven't learned yet. Right? So there are differences. Okay? Now that's something that's very key to have in mind, is that the super and the sub, or the parent and the child, don't have to be identical. They are just related. And the same is true in OOP. So let's have a demo. So as a class, come up with 3 different categories of things. So for example, sports, vehicles, animals, nothing too specific. Our categories have to include lots of different objects, with objects being used deliberately. So I have pre-prepared a little diagram here, but if there was a class then I would get them to give me the categories, but seeing as there isn't, I've imagined some that they might pick. So if I just look for my pen. So vehicles, if we list the attributes of vehicles, well, vehicles all have to have a top speed, and okay, that's broken. I do apologise, I'm going to have to type. So vehicles all have to have a top speed. They have to, what else? Well, they have to have carrying capacity, right? Fuel, etc, etc. Okay? Animals, well, animals have to eat. So again, food. Animals, well, they're all part of a species, aren't they? I think I spelt that right. Some of them might have tails or legs, but they don't all have them, so we need to be more specific. So I'd ask the class to think of what all animals do. Well, I'm pretty sure that all animals breathe, right? So we could have breath, and that could be an interval of how long in between breaths. Not sure who can last 5 minutes, but who cares. And then we've got sports. So I suppose sports, you would have goal, right? So what's the aim of it? So that could be lift weights or score a goal, etc. Right? You would have number of people playing the sport. You might have team, and then that could be a Boolean yes or no, and so on and so forth. Right? Now, what I want to ask the class to do is to think of some subcategories, right? So to name some things that could be considered vehicles. Okay? So we would have, again, I've got to apologise, my graphical pen is stuck as a eraser today, so I'm going to have to do it via mouse. So under vehicles we might have cars, right? So cars could be sports cars, but cars have a top speed, carrying capacity and fuel, but they also have wheels, right? So we would say that they inherit those attributes from vehicles, but they also add wheels. It's got a horn, right? So that could be the type of sound the horn makes, and etc, etc. So we have cars, there's one. Well, what else can we have? Well, we could have boats, right? And again, no wheels, but boats might have a sail, yes or no? It will have a rudder, right? And, you know, buoyancy, I suppose, right? However, you would hope that buoyancy isn't really in question with the boat. So, and then we go on with that, and for animals as well, what I'm looking for is something like cats, and again, something like horses, maybe, or whales would be a better example. And then from cats, we could have house cats, or pumas, I suppose. And then the idea of this is essentially to build up an inheritance tree, right, without using any of the notations that can look quite intimidating. So essentially we would have a cat that would have a roar, right, it would have fur, it might have a pattern on the fur, and then a house cat, we would say that the roar would be a meow, right, whereas with the pumas the roar would be more of a growl. And then the good thing about that is that the roar and the growl, this can be used as a good example for polymorphism, and so to root that in their minds here, we can come back to that later. So anyway, so I'd want to spend about, you know, a good 10 minutes discussing this with the class. Okay, so let's continue. Okay, with a practical demonstration, we're going to change our cup of tea class to inherit from a superclass called drink class, right? So, and with fill in the blank space, I did originally have something there, but I do apologise. So, we're going to have a think about what the drinks class might contain. We'll also make another subclass to inherit from the drinks class. So, what will this class contain? And can we add attributes to the subclass that aren't in the parent class? So that's a question to the class. So obviously the answer I'm looking for is yes. Right? So at this point I would ask the class to come up with another example of a drink that we could do. So you know, Pepsi or cola, or essentially what I'm looking for is a cold drink, and that will become clear as to why in a bit. So let's make, first of all, a drink class. Okay, and here I'd ask the class for attributes that all drinks would have in the definite. So we could do self.volume would be a good one. Self.temp, right, all drinks have a temp. And we could do self.flavour, I suppose. Right, so then here I'm going to do volume in, temp in, and flavour in. Okay, and so now quite quickly that's our drinks class. Now let's think about the cup of tea class. Cup of tea. Well, actually, before we do that, what can you do with all drinks? Well, you drink them, don't you? So let's do that. Self and amount. Okay. So, self.volume equals volume divided by 2. Oh, sorry. My bad. Self.volume minus equals amount divided by 2. Okay, cool. So, now for the class cup of tea. The first thing that you do when you're creating a subclass in Python is that you pass the superclass as a parameter. Okay? So you do class, subclass, superclass. Okay? And I'd pause to make sure that the class gets that. Right? And now here we're going to do, you can see it looks different, right? And we're just going to skip over this line for now. I'm going to explain super later. But essentially, that just calls the same in it, right? So now, if we wanted to add attributes to the class, right? So we might want to add sugar and milk, let's say, right? So, oh my apologies, sugar in and milk in. So, self dot sugar equals sugar in, self dot milk equals milk in. Now, at this point, the two questions I would ask would be, one, do we have to redefine drink? Or can we call cup of tea dot drink? Right? Well, yes we can. Look, the editor has told us we can. So no, we don't have to redefine drink because we've passed this whole class into here. That's all fine. Okay? So, now that we've got that, let's have a talk about what super means. So, super refers to the parent or superclass of the child or subclass it is called from. So in our cup of tea class, it refers to the parent's class, drinks class. So this is where I'd ask the class, does anyone know what super.init would do? And the answer, of course, is it calls the parent class's initialization function. Again with the two N's. So if you look here, this is essentially the same as writing that, right? Because it just calls the function. Yeah? So all that means is that in any class, if we wanted to add attributes, then and keep all of the original attributes, we simply call super and then we add the extra attributes ourselves. Now I'd probably stop with the class and maybe do some other examples at this point, but hopefully that this is a fairly simple concept to grasp in terms of that just refers to this. Okay, so now this is a challenge for the class. First of all, I want them to make me a vehicle superclass that has the following attributes and the following methods. So it has to have a top speed, a current speed, a colour and a current fuel. And I want it to have methods to increase current speed and to refill fuel. Now this is an excellent test of whether they can remember the self rules from last lesson, as well as just a bit of practice in making a class in Python. So let's go through it and do it ourselves alongside them. So whoops, I need to define the language. Okay, so class vehicle and def init. Okay, self dot top speed, self dot current speed, self dot fuel, self dot color. Okay, Right. So top speed in, current speed in. Now, in terms of me using in at the end, that's just to make it really clear to the class what are parameters and what are attributes in this case. Okay, and then we can do equals top speed in, equals current speed in, equals fuel in, and equals colour in. Okay, perfect. Now we'll do a refuel. Okay, and what have I missed? That's the first point where I would pause the class and ask them what I've missed. I've, of course, forgotten to add self, right? So self and the amount of fuel that we're going to be refueling. So then we simply do self.fuel plus equals amounts, right? And then def accelerate. And, oh, well, I suppose we could do amount. Self.current speed plus equals amount, and then we would have a little check if self.current speed is greater than self.top speed, then self.current speed equals self.top speed. And again, this is just a good test to make sure that they've remembered what self does and how to access an object's components versus accidentally creating ones that will just be lost outside of the scope. Okay, so here's one that I made earlier. And then we would talk about this and make sure that everyone understands everything and maybe get some of the students to share their own. So now we want to make a car subclass, right? So what attributes is a car going to inherit from the vehicle superclass? What extra attributes might you add? And this would be a good chance to discuss it with the class. So the answer is it needs number of wheels, make, air conditioning, and I also want it to have an extra method called honk and something to turn the air conditioning on and off. Right? So again, I'd pause now to make sure that the class has understood the idea and possibly either spectate, monitors, or look around the room as they're doing this. So the main things I'm looking out for is class car and that they pass vehicle through it, right? That's one key. The second that I'm looking for is that they know how to set up a subclasses in it. My eye does it for me, but I'll be looking around for this throughout the room, and the idea that that means that it has all of these attributes, right? That the super is what makes it inherit them. And then I would add aircon in, what was it, wheels and make. Wheels in and make in. Then let's try and keep camel case consistent here. Okay, so we could do self.aircon equals aircon in, self.wheels equals wheels in, self.make equals make in. Okie dokie, so that's all of the new attributes. Very, very good. So now let's do the extra methods. So first of all, actually before we do that, I would check that no one has redefined refuel or accelerate, and if they had, then we'd spend some time discussing why they didn't need to do that, which is because of this, that beauty right there. Okay, so let's make honk, and this is very simple. As a challenge, I might ask them to allow the user to define what sound the car makes, but for now, we just want to return honk. And as well, aircon switch, self, and here we could just say self.aircon equals not self.aircon. Okay, and hopefully the not operator is quite well understood. So Here's one I made earlier again. And so we'd spend some time going through this. What's the same? What's different? What do we think has been inherited? Has there been anything that hasn't been inherited? Well, the answer is no, but good to see. And then we can see it calls the super vehicle class initialization, and it adds extra attributes. Now, this is a very important rule. If you don't add any attributes to a child class, you do not need to rewrite init. Okay? This is because it inherits the parents in it automatically. So if we were happy with the car not having any of this, right, we could just leave this blank. Okay? Because when we call in car like this, you can see the IDE has figured it out as well. It will simply go to this. Okay? It's not a very important rule. I suppose if you like the extra readability of that, just because, that's fine. But I find it tends to make it a bit nicer and save a bit of code. Okay, so now quick pause and recap to make sure the class knows what a superclass is, what a subclass is. What does a subclass inherit from a parent class? Well, the answer is everything unless you specify otherwise. Can a subclass have attributes and methods a parent class doesn't? And the answer is hopefully yes. Okay, so now we're going to look at polymorphism. And polymorphism describes how a child class can differ from a parent class. So we've already seen some examples of this. So at this point I'll ask the class to pause and give me some. Okay, before I have a drink of some lovely Vimto. So, hopefully the class can remember that the car, right, has aircon, wheels and a make, that the vehicle didn't. And similarly to our cup of tea class, right, tea has sugar and milk. And actually, now that I think about it, I forgot the second part of this activity. So, with the class, I would make a Pepsi drink class, which probably has the same but without the milk. Okay, so my apologies. Okay, so, oh, whoops, yeah, okie dokie. So just like you're all related but not identical to your parents, a child class is related but not identical to its parent class. So polymorphism refers not so much to the attributes but to the behaviour of a subclass differing from its superclass. So this is a fancy way of saying that the shared methods are different. So when I say shared methods, I mean, so as an example, my cat, my house cat, Thursday, and a lion both make noises from their mouths, right? So they both have a shout. We could say it's a shout method. But my cat Thursday purrs and mews, whereas a lion roars, right? So they both have the same method, but the behaviours of the method are different. And there's two different ways of doing this. One is called overriding and the other is called extending. So let's look at extending first. Okay, so I'd like the class to create a class called football fan with me. So the football fan has the following attributes: number of games attended and the type of team supported. It's also got a method called chant, right? Now chant returns a chant including the supported team. Okay, so we're also going to create a subclass called Mega Football Fan. Now the Mega Football Fan is quite a lot more louder and it's more excited about the football than the normal football fan. And because of this, I'm going to show you how to extend the chant method to show its increased enthusiasm and support. Okay, so let's once again. Okie dokie. So, class football fan, and just to make it clear, this would be a demo that I do that the children are welcome to program along with if they want. So let's do again def init self dot num games, we'd say, and self dot team. Okay, and then we would just do num games in and team in. Okay, and then right, whoops, okie dokie. And then let's make the chance self, and then we'll probably do chance equals I really like plus self dot team. Okay, and then return chance. Okay. And then, you know, I prefer to do string concatenation like this in front of a class because the whole, you know, F brackets, that, it can look a bit confusing. Okay, so there we go. Now we're going to create the Mega Football Fan. So the Mega Football Fan shares the same attributes as the Football Fan, right? So we don't actually need to create another instantiation. So, sorry, another initialization. So we can leave def init blank, right? Don't need to do that. But we do need to put def chant, right? Now, here's what I'd ask the class, is at the moment, is this any different from this? Well, the answer is no, right? Because return super.chant is just returning this, right? So what we want to do, in fact, is this. We want to say chant equals super.chant, right? And then I would check to make sure, so then I would ask the class, what does chant mean here, right? And chant is I really like plus my team, okay? But because he's shouting at this Football Fan, we're going to do chant.upper to convert it into uppercase. I'm going to say chant equals chant.upper plus an exclamation mark at the end, right? And then we can simply return chant, okay? So that is called extending because we have extended the function. We've added another line, or 2 lines, okay? So we call the function here, right? Call that there. We set that to chant, and then we've extended it to change the behavior. So at this point, I would say, let's say I make footy fan 1 and footy fan 2. And footy fan 1 is a football fan who's been to 5 games and supports Manchester City. One of the only 2 that does. And let's say that footy fan 2 is a mega football fan and supports the correct team, which is Manchester United, right? And he's been to 25 games. Now, this is the point where I'd ask the class, what do they think happens when I call footyfan1.chant, right? And what happens when I call footyfan2.chant? And then if I wanted to, I could run this. I'd have to save it first, but so we could run this and we could see that this is I really like football and this is I really like football, all in caps with an exclamation mark. Right? Okay, so hopefully that's clear to the class. And again, here's one I made earlier. So we can see lackluster chant, and then again, we call the super classes chant, we put it in uppercases and add an exclamation mark. Okay, so now we're going to talk about overriding, which to me sounds very sci-fi, but like a lot of things in computer science, unfortunately it isn't. It actually just rewrites the behaviour of a method completely, right? So here's my question. Would you call super if you wanted to override a method? Well, the answer is no, right? So we're going to make a third type of football fan now, one with a drum. And instead of chanting to support their team, this football fan is going to bang on their drum really loudly to support their team. Okay, so and this time, instead of extending the chant, we are overriding it. Okay, so at this point I'd ask the class to do this on their own, and I'd give them some time, and then I'd do a demo like so. Okay, so let's say we have a class musical football fan. Okay, and the first question is, will this inherit from football fan? Well, yes it will. Okay, because we want all of the attributes. So instead now we're going to say def chant. Right, now do we want the super? No, we don't want the super. Okay, so we leave that blank, and then we simply say return bang 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 I love myself.t. Right, okay, so simple as, really. And then again, I could ask the class what they think will happen if I make a footy fan 3, who's a musical football fan who's been to 125,000 games and supports Liverpool. Well, what would happen if I were to do footy fan 3.chant? What chant would I get? Well, I'd get the drum, wouldn't I? Okay, so hopefully we're all happy on that. And again, no super is called because we don't need it. We're not interested in what the original chant did. We want to override it. Okay, like rubbing something out and rewriting it. So now, benefits of polymorphism and a learning activity, because I've put two polymorphs at either side of the screen. One of them is a changeling, which is a creature whose original look is disgusting but can morph into anything it wants. And of course, my favourite, a mimic from Dungeons and Dragons. So, what are some benefits you can think of, besides scaring travellers and getting to impersonate people? Well, it saves on writing code, doesn't it? So we didn't have to rewrite chant for the Mega Football fan, it just added an extra line, right? So you see here, yeah, you see how this could have been 2 more lines. Now, it's not really that obvious in a project this small, but it's something that I'd make very clear to the kids, that the bigger your project gets, the more and more time and code you save by using object-oriented programming well, right? And again, something that computer scientists do that's a bit confusing to explain is that when I say save code, I don't even really mean make it run any faster. It could. An object-oriented programming can be very efficient, but what I mean is it makes it more readable, right? Because you're not reading the same bit of code over and over again that's just sprawling down the page. It makes it a lot more compact, which is nice, especially for larger projects. It also abstracts the specific behaviour of an object, right? So what I mean by this, what do I mean by this? Well, I mean that when we call chant, we don't care that football fan 1 is a football fan, 2 is a mega fan, and 3 is a musical fan. No, we don't care, right? We just want to hear them chant. And we don't need to know what type of chant we're calling, right? Because it's all the same. So now imagine that you are new to the project and you don't actually know what these things do. You don't need to know the inner workings of it, right? So if anyone has used a library, for instance, what's a good library as an example? Math, right? Math.floor, I believe. Yeah, there we go. Math.floor, right? So math.floor, as it says, it returns the floor as x as an integral. So it essentially says the largest integral, the largest integer that comes from dividing x, right? Now, we don't need to know how floor works, yeah? Because we only need to know 2 things about floor: the parameters it wants, right? Which would be x and the divisor. And we need to know the output, right? Don't we? which is an integer. That's it. Yeah? We don't care what happens in floor. We don't care what happens in the maths library. We just care about the input and the output. And that is because of object-oriented programming. And what we say is that it has abstracted that away from us. Now, abstract, it just means hidden, right? I think it's good to start learning that vocabulary, but you don't, at this stage in their education, think it's a bit much to ask for them to properly understand the idea of abstraction. So again, here is a good demonstration. So we can see on the left, that is written using inheritance and polymorphism. On the right, with neither. So the first things that you can see is that we've had to redefine initialization every single time. We've also had to recreate the chant every single time, and you can see actually that even though it's quite a small function, chant is actually less, it's more efficient here, right? It's the same number of lines, but you know, you get my point. Okay? So, and now finally the recap. So, what is inheritance in object-oriented programming? Well, it's how a parent class can pass on certain attributes and methods to a child class. What is polymorphism? Well, polymorphism is how a child class's methods can differ from a parent class's, right? So we would talk about extending or overriding. And then the benefits and the cons. The benefits of polymorphism and inheritance. Well, again, we've just said it. Right? So yeah, that's my lesson on inheritance and polymorphism. I hope you've enjoyed. I'd like to thank you for the opportunity of having me through to phase 2, and I look forward to hearing back from you.